All right, so what known series should we compare this to? A good question to ask in scenarios like this are, first of all, what do we suspect this series does? Do we suspect that it diverges, or do we suspect that it converges? We can see readily that as n approaches infinity, this is approaching sine of 0, which is approaching 0. So this doesn't tell us anything. If the result was that it wasn't 0, then we could have deduced that this diverges. But since it's 0, we don't know. Do we suspect that it diverges or converges? It's really hard to say. The terms are going to 0. So maybe it converges, but then again, the terms of the harmonic series also go to 0. So it's not so easy to say what happens with this series. So back to the original question. Who should we compare it to when we use the limit comparison test? Let's try the diverging harmonic series. So as n approaches infinity, sine of 1 over n approaches 0, and 1 over n approaches 0, so this is the indeterminate form. We'll use L'Hopital's rule. So the derivative of sine of 1 over n, don't forget the chain rule. We'll divide that by the derivative of the denominator. So nicely these factors cancel out, and as n approaches infinity, this is approaching cosine of 0, which is approaching 1. So this limit is equal to a finite value 1, and by the limit comparison test, our series must behave the same way as the series that we compared it to, which diverged. So our series diverges. Now what's absolutely required as you do this work is mentioning who you're comparing it to, and it should be a known series, so we know that it diverges. Doing the limit expression correctly, and then in your conclusion, naming the theorem that you're using, the limit comparison test. Our conclusion is that our series diverges.